In this video, we're going to be using trigonometry to solve some application problems. Before we do that, there's a couple terms that we need to define. An angle of elevation. Elevate means to look up or to go up. So an angle of elevation would be the angle that opens upward. So we could say it's this one, or if we flip the triangle, it's over here. It's always the angle that is opening upward. An angle of depression. Depression means to feel down. So if you think about that, it might help you remember that this is the angle that opens downward. So now we need to flip our triangle upside down so that we have angles that are opening downward. We'll see some problems with those terms in it, and hopefully knowing the definition will help us draw the right triangle. All right, let's do this first example. 13-foot conveyor belt is being used to raise and lower some packages or supplies, and it's elevated at 15 degrees from the ground. We want to state the trig equation we would use to find the distance from the base of the conveyor belt to the loading dock. So a base length is going to be on the bottom. The conveyor belt is the leaning side. That's going to be our hypotenuse. That length is 13. And we have our angle of 15 degrees. So if we have the adjacent side and the hypotenuse side and an angle measure, we can use the cosine ratio to set it up. So the cosine of our angle, cosine of 15 degrees, is equal to the adjacent side over the hypotenuse side, or in other words, x over 13. Now let's find the distance. So let's solve this equation. We're going to set it up as a proportion and cross multiply. The cosine of 15 times 13 is about 12.6 feet. Let's try out another example. In this example, we're trying to get a cat that's stuck up in a tree. We grab a 16-foot ladder and we lean it against the tree. So our leaning length, or the hypotenuse, is going to have a length of 16 feet. We lean it against the tree at an angle of elevation of 79 degrees. So the angle that opens upward is going to measure 79 degrees. And we want to find the maximum height we can reach to grab the cat. So a height is going to be our vertical length. So we're going to solve this opposite side of this right triangle. So since we're talking about the opposite and hypotenuse sides, we're going to use the sine of the angle to solve for that missing side. So the sine of 79 degrees should be equal to x over 16. And we just cross multiply to solve this proportion. Sine of 79 times 16 is about 15.7 feet. So if the cat is any higher than that, we might have to stand on our tippy toes, or we might have to grab a longer ladder, or we might have to increase our angle here. If we scoot the base of the ladder a little bit forward towards the tree and then lean it, it's going to be leaning at an even greater angle, and so maybe we can reach a little bit higher there. All right, one more example. This time we're piloting an aircraft. Our altitude, or the height at which we're flying, is 30,000 feet. So a height or an altitude is a vertical length. That'll be that side of our right triangle. We are 6 miles away from the shore. That would be our ground distance. At what angle of depression are we going to have to tip the nose of our plane down so that we can make the landing? Well, because we're talking about an angle of depression, we're going to draw our triangle upside down so that we have an angle that opens downward. So now our ground length is opposite, but still an equal length here. That'll be 6 miles. Our altitude is still over here, straight up and down at 30,000 feet. So the first thing we need to do is make sure our units are in the same units. So miles and feet are not the same. We want to convert the miles to feet, or maybe we convert the feet to miles. You can do either. I'm going to convert the miles to feet. There are 5,280 feet in every mile. So if I multiply that by 6, then we get 31,680 feet in 6 miles. So now I know my two side lengths. I can use that to find my angle measure if I just use the right trig ratio. Since we're involving the opposite side and the adjacent side, that goes along with tangent. TOA helps us remember that. Tangent of an angle is opposite over adjacent. So now we just plug in the opposite side value, or 30,000, the adjacent side value, 31,680. Plug it into the inverse tangent function on our calculator, and it tells us our angle measure is about 43.4 degrees. So in order to travel 6 miles horizontally and drop 30,000 feet vertically, I need to tip the nose of my plane down at least 43.4 degrees. If I do any less, I may overshoot my airport. If I do it any more, I might crash into the ocean. So we're going to try and do about 43.4 so that we can make it just to the shore and hopefully make a safe landing for all of our passengers. So there's just a few examples of applications of trigonometry. There are tons of them. Good luck using trigonometry to solve them.